Welcome to my presentation. In this presentation, let us see some simple operations related to matrices, and we will see how we can multiply matrices with some constant numbers or constant terms. So let's define a scalar multiplication. If A is a matrix and if it has elements Aij in them, and if it has a size of m by n, and if C is a constant term, then the scalar multiplication can be defined as follows. Then C, which is a constant, multiplied to a matrix A, can be written out as C times, with respect to elements Aij, we can write this one out as C times Aij. That means the constant term would be distributed to every one of the elements in that matrix. So that's the definition. So let us understand this property of scalar multiplication of matrices with a simple example. Let's take a simple example. In this example, if A is a matrix, and let's say the size of this matrix is 5, 4, 4, and -3, 1, 2, let's say. And then we have a matrix B, which has a size 1, 2, -7, and then 0, -5, 1, like that. And then if we want to find 2 times A minus 3 times B. How do we do this? So in here, what is happening is we are multiplying a constant to a matrix which has elements in them. We are taking a constant -3 and multiplying it to elements inside matrix B. So let us see how we can proceed with these types of problems. Step number 1. We're going to write this one out. 2 times matrix A is 5, 4, 4, -3, 1, 2. And then the second matrix is -3 times 1, 2, -7, 0, -5, 1. So the way we do the distribution in algebra, we're going to follow the similar rule here. We're going to take this 2 and then distribute it to every one of the terms inside the elements of the first matrix. We're going to take this -3 and then distribute it to every one of the elements inside the second set of brackets, which has for the elements in there. So the way to do that is as follows. We'll call this one as step 2. In here, 2 times 5 is 10, 2 times 4 is 8, 2 times 4 is 8. In the first, we got the first row. In the second row, 2 times -3 is -6, 2 times 1 is 2, 2 times 2 is 4. We got all the elements in the first matrix. And in the second matrix, we can leave. Let us do this. We'll put it as a positive sign and then distribute the -3 to every one of the terms. -3 times 1 is -3. -3 times 2 is -6. -3 times -7 is positive 21. -3 times 0 is 0. -3 times -5 is positive 15. -3 times 1 is -3. So we have all the elements now. It is just a matter of adding these. We have done a scalar multiplication of matrix. Now we are just performing the addition process. So in step number 3, we will complete this process. So the way we do the addition, we're going to add the corresponding elements from the first matrix with the corresponding elements of the second matrix. For example, here, first row, first column, to first row, first column of those two matrices, and then we will say it as we write it out. So we have 10 minus 3, then 8 minus 6, and then 8 plus 21, and then negative 6 plus 0, 2 plus 15, 4 minus 3. In here, this is in the first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, right? Therefore, when we simplify this, this is going to simplify as follows. 10 minus 3 is going to be 7, 8 minus 6 is 2, 8 plus 21 is 29, negative 6 plus 0 is negative 6, 2 plus 15 is 17, 4 minus 3 is 1. So in here we did a scalar multiplication of matrix, and then we performed the addition process, and then we were able to come up with the answer. And therefore, as you can see, the size of the original matrix was 2 rows and 3 columns. It was a 2 by 3 matrix, and we've added it to a 2 by 3 matrix. The resulting matrix is also going to be the same size of the original matrices, 2 by 3. In my next presentation, we shall look at how to do multiplication of matrices.